All right, we're under the hood, and here's the wire coming through the firewall. I just drilled a hole in there, and when I get all this figured out and done, I'll put some sealant around there to make sure we don't have any water leaks. I think I'm going to actually change the routing on this so that this wire is behind these. I don't know, but this is going to get all tie wrapped in place. Right now I'm only at the point where I have it in, but there's no tie wraps. So I don't know if you can see that back in there. All right, so all that's going to have to be rerouted there. You know what? I think I might be changing how that is routed back there, because it's going on top of the air compressor. This is the air compressor output. This thing gets real hot. So I might pull that out and go below it, which that won't be too hard to do. So let me show you what's going on underneath the bus. All right, so there's the transmission. That's the front. So here's our wire here that is coming from up top. So like I said, I think I'm going to actually change the way that's routed. Maybe go on the other side of these. This is the fuel lines, and yeah, that's going to be a pain. But anyway, so we ran this in with all the existing wiring all the way down the bus through there. And like I said, there's no tie wraps on this yet. I just got it pulled in place. Okay, and it's running all down the frame along the side of the fuel tank down there, and you can see hanging down there, maybe you can, by the differential on the right side, our right side, there's the wire hanging down, and I'll be hooking up a trailer plug back there as soon as I get one. Okay, this is the left side of the frame, and right in this area there was a backup warning horn that actually, even though it was crushed like that, it still worked, and I don't care to hear that damn thing, so I removed it. I've got to cap off the wires that went to it and secure them up there. But here's my trailer wiring coming from up front. I added in my ground here. I ground off all the paint, and then I put some black spray paint on there while it was still wet, and then made this connection. And I added this little clamp here so we won't break at that juncture right there. So this is a number 10 wire. It's supposed to be white, but I only had red. I still got to tighten this up. I will once I get all the fasteners, which somewhere between Amazon and UPS, the bolt kit never made it here. So I could, looking up in the Amazon website, they tell you to call the manufacturer for any problems, and I did, and the guys there at Draw Tight were really great about just sending me out a bolt kit, or I could have returned the whole hitch and got another one, but might have just got another one without the bolt kit, right? Good afternoon. It's January 12th. I think it's Wednesday, and I think I'm finally done with all the chassis electrical on the bus. So this is going to be a long one. So let me just start at the beginning and tell you the whole story. So the bus electrical system has wiring configured for left directional, right directional, and brake in separate circuits. The medium duty or RV trailer connector circuits don't have a separate circuit for brakes. The left turn signal and the right turn signal also work as brake lights. But in order to do that, you have to get a converter or make your own. And I made my own. It might cost more in the long run, but I think I got something way more robust and way simpler to diagnose and fix if something's going wrong with it. So first, let me give you the lowdown on how it all works. So it takes at least 3 relays. There's another way of doing it with 4 relays, but I don't see the need for it here. So there's the brake signal has to go into a relay where when you step on the brakes, it'll activate the coil on the relay and switch it from the normally closed to the normally open. And this is getting power from a fuse. So as it sits right now, if you step on the brakes only, power is going to come and activate this coil from the brake light switch. That is going to activate this relay and connect the normally open circuit. Then power can flow from this fuse into the normally open contact and up to the left and the right turn signal relays on their normally closed contacts, and then run out to the left and right lights. And I have a fuse for the left and a fuse for the right. All right, so that's stepping on the brakes only. If you only are using the directionals, all right, so you'll get an input to the coil of the relay, and that'll flick this from normally closed to the normally open. This normally open is getting power on this brake relay on the normally closed circuit. So the 12 volt power is feeding through this relay and provides 12 volt power to the normally open on either of these. So if you activate the coil in either of these left and right, it'll provide power to the output through the fuse. So now if you've got your foot on the brakes and you've got power coming onto this normally open, feeding power on this circuit and this circuit, both the yellow and the green, the left and the right, will get 12 volt power. Now, if you turn the blinkers on at the same time you're holding the brake, the blinker will send power to the coil, and it will take this normally closed and switch it to the normally open. But because you've got your foot on the brake and this has been activated, there's no power on this other leg right here. So the light will blink because we are taking power away. Instead of power coming in here, we're taking power away every time this gets activated. So the interesting thing is, just like with the converters you buy, when you step on the brakes, the trailer light blinking will be in reverse to the vehicle braking, vehicle blinking. All right, so excuse me. That's how these 3 relays convert a separate brake, a right and a left blinker. So what else we have in our electrical system is I have tail lights, and instead of tying into the chassis tail lights, I have a relay. That relay gets power from the tail lights circuit on the bus, which is a minuscule amount of a load. And as soon as you apply power to this relay, the normally open will get power from this fuse. And same thing goes with backup lights. It works the same way. And I thought the brake controller was going to be on an ignition circuit, but I was mistaken. The instructions from the brake controller indicate to have its power coming directly from battery source. So this relay is not connected and not being used. And lastly, the 12 volt positive gets power all the time through the fuse. So the fuse block that I chose to use is this one right here, which this one's kind of hacked right now. Comes with this nice cover. I got this on Amazon. And it's got these two little nuts to hold the clear cover on. This is a marine grade quality fuse block. It's got a positive bus bar and a negative bus bar. That's what these large studs are for. This one's the positive. It's got a little plus right there. And this one is the negative. The negative feeds this line of screws. So you can hook up all your negatives to this as you normally would in a boat that doesn't have a grounded chassis, right? Or any other system where you don't want to use the chassis ground. All the positives for each fuse gets power from this stud. Power goes through each fuse and comes out of these terminals. That's the way this is originally configured and originally designed to work. Well, I needed two circuits for the left and right directional to pass straight through and not be a powered source. You can recall on this right here, power is going to come from either this wire or that wire and run through the relay and then through the fuse and then out to the trailer. Everything else is getting power out through the relay, the other direction. And each of the others needs a power source all the time. So I bought two of these. And I took these two terminals out. They're just little, what you see right here, and a little bracket on the bottom, and it's a female socket that the fuse plugs in. And let me show you the one that I have installed on the bus now. If you notice, this was originally the negative bus bar, and it's been removed. I took the two terminals out of the other one and put them in here. I had also to cut the positive bar that runs from here across the top here, and I cut that bar off right between these two fuses. So only this one, this one, this one, and this one are getting positive power, and it runs through fuses and then it runs out. And that's our tail lights, our 12-volt continuous, the relay that I thought was going to go to the brake controller, but now it's just vacant. And then this is backup lights. These are the power source for the relays. Here we have the left and the right output from the relay, each of the left and the right relays, coming here, going through the fuses, and here it runs out to the bundle of wires that run out to the trailer plug. Here's our 12-volt that's always hot, that's running out to the trailer plug. The orange wire and the brown wire you see in the back here are coming from the relays. It's coming from the back side of the relay here, and the brown one's coming from the back side of the relay here. Those are the normally open contacts on the relays. This relay, to activate the coil on the relay, I tied into an ignition circuit of the original wiring on the bus, and I needed to put a fuse in that in case something went wrong somewhere in this. I wanted it to blow a fuse, like I would have only a 2 amp fuse in here or something, so it wouldn't blow the fuse that is powering that accessory circuit on the original equipment of the bus. Since the relay takes a minuscule amount of power, a 2 amp fuse is all I would need. But I don't have the need right now for an accessory to add onto the bus, and I may never. But since I had the extra slot, I left the relay in here and everything is ready to work. It's getting power. If I put a fuse in here, this relay would get power through this big blue wire here, and the back side of the relay right now, back here, there's no wire connected. So if I did need to connect an accessory, I mean, whatever I want to put on the bus one day, who knows. But I will put a fuse in here for activating the coil of the relay, and a fuse in here to carry the load. All right, and here's what the whole setup looks like. There's our left turn relay, our right turn relay, the brake relay, which I showed you a little while ago. This is the tail lights relay, the backup relay, and the auxiliary relay. I'm going to print some labels and put them on there. It'll make it a little bit easier. So everything has its own circuit protection for the trailer light wiring. No loads from the trailer light socket load the original chassis electrical system, except for this big orange wire right here, which is feeding power to this. And that is basically going straight to battery through this 100-amp fuse. This is the fuse that provides power to the chassis air conditioner. The trailer brake controller gets battery power through this wire here. This runs around to here, battery plus, which picks up power through here, which runs through there, goes through the floor, and goes right to the battery with a giant mega fuse. So we've got full battery power here, and behind here, battery power is going through this gray wire. Oh, there you go. Connected to the back of that mega fuse. Power is going. By the way, I put the terminal for these smaller wires on the back side of the mega fuse, and the heavy wire on the front side of the mega fuse. So when I tighten the nut, the terminal won't get all tore. The small to the light duty terminal won't get all tore up from the torque, where the big terminal can handle it. But anyway, here's my 20 amp automatic reset circuit breaker, power battery side and load side. The gray wire goes inside this harness. This is the same harness where all the wires are going out to the trailer plug, but I used it to carry this 12 volt power through there, and it's currently coming out right here in this. There's 3 wires in here. I've got a ground wire, the power wire I just told you about, and the blue wire that goes to the trailer plug to activate the trailer brakes. So as soon as I get that trailer brake controller, that's going to be installed right here, which I'll show you how that is going to sit. All right, so I adjusted my seat back to more or less driving position, and I'm sitting in the driver's seat. And the brake control is going to sit right here underneath the shelf. Normally they're designed to sit horizontal, but like under the dash. And there's really nothing here. It's just a bunch of plastic. Nothing for me to put it on that's convenient. So I'm going to put it here sideways, and the air line will be at the top, and it'll run back through here and circle around and then run through the firewall and connect on that orange hose. And then all the electrical I'll have tucked up, attached to the bottom side of this. These 3 wires right here will be up on the top, up out of the way. So all we'll see is the brake controller. What's really neat about the brake controller is it's got a little LED light on it that varies in brightness with the brake application, so you can see that it's actually working. And it's got some really neat safety features too. I would encourage you, if you're going to use electric trailer brakes, this is the only thing that I've been able to find, and it's a little on the expensive side, but I think it's the one to have. So there you have my opinion on the air brake to electric brake controller. A Hayes automatic electric brake controller, air actuated, 100 400C is the model. And I bought this from eTrailer.com. I think it was like 266 bucks. And the way this works, you connect air pressure onto this little cylinder back here. And that moves, I think it's physically moves a mechanism in here that is like a rheostat deal. I don't think this is electronic. I think it's mechanical. Let's see. And here is how that gets wired up. You get a black wire with power directly from the battery with a circuit breaker. This is a typo in this diagram. It says 30 amp fuse here, but if you read here, the black wire is the positive voltage power supply using a 12 gauge wire connect through a 20 amp automatic reset circuit breaker. So I went with the automatic circuit breaker, not a fuse, because if you get any intermittent little short circuit in your brakes, you want the power to come back on, not just pop the fuse and you've got no trailer brakes. So I found this to be the more reliable information here, and 20 amps is more than enough for what I'm going to be pulling on here with only 1 or 2 axles. So the black is power directly from battery, and white is a ground, and the blue wire goes out to the trailer brakes. And there's your air line. So the interesting thing about the air line is they tell you you need to have a two-way check valve. And the reason for that is they want you to be able to get air pressure from either the front or the back. And this little two-way check valve will allow pressure from either of these to go into the small line, but not allow the pressure to go into the other service line. I'm going to go show you this underneath the hood of the bus, and you'll see what I mean a little bit better once you see the real thing. So hang on one moment, I'm going to go outside. All right, this is the treadle valve, or the air brake valve, or the foot valve, whatever you want to call it. When you step on the brakes, this is what gets activated. So here's the check valve I was telling you about on the diagram. It gets air pressure from the green side, and it allows it to go down this kind of orange hose, or it gets pressure from the red side and lets it go down to this hose. This red hose here goes to the brake light switch. So all I've got to do is tie into this and send air pressure from here into the brake controller, and I should be good to go. All right, so we're here at the back of the bus, and we've got our light socket, and I tested every one of the circuits with a handy little trailer socket tester. This guy here, you can get these all over the place. I think even Home Depot sells them. And the little LED light comes on for 12 volt positive, left, tail or markers, right, backup, and brake. And I've checked, and every one of the wires circuits is correct. So I'm going to show you the hitch now. This was a great find. I've been laboring over where am I going to get a hitch for quite a while. The hitch is made by the Draw Tight company, and the model is 41938. And I'm going to crawl under here and get you a better look at how it's installed in the bus. So here we go. This is the forward side of the hitch. It's got 3 mounting points towards the rear, and 1 mounting point towards the front, right there. I don't have the bolts in yet because the bolt kit and the installation instructions were missing when I received it. I bought this hitch off of Amazon. I think it was like 260 bucks. I think it's a great deal. It is way super duper strong material. This is 5/16 thick steel. So the chassis of the bus had this hole in it already, and the side to side distance of the bolt hole is within like 1/16 of an inch, close enough that a 1/2 inch bolt fits through here, but without me drilling anything on both sides. So actually I had these 1/2 inch bolts in there originally, but later, after I got these other holes drilled, which I drilled out to 9/16 of an inch, I came back and took the little edge off that was in there, so all the holes can fit a 9/16 bolt. Because I don't know what size bolts are coming with this thing. I imagine they're 1/2 inch. But anyway, I got on the Amazon website, and it indicated I needed to call the manufacturer, and they provided the phone number on the Amazon website on my purchase. So I called it up, and the guys answered the phone right away, and I told them the dilemma. I did not have a bolt kit, and they're having a bolt kit mailed to me, no charge. Unfortunately, it's coming all the way from Mexico, and it's going to take about a week to get here. So in the meantime, this hitch is just going to hang by these bolts. I'm not towing anything, not anytime soon. So as soon as that bolt kit comes in, we're going to get the rest of the bolts in and torque it down. So it's something I had to do to make this thing fit. I did have to do slight modification. This is the fuel tank back here, and this is the guard, and it's also the support for the rear of the fuel tank. So I don't know if you could tell, but this piece of metal used to come out this far all the way up to here. I had to cut off this area. I didn't have to go that far, but I just went all the way, since that was what I decided to do. Behind here, there's a flange welded on, and these two bolts here are holding this in place. So all this material out here really wasn't doing that much anyway. This is I think 5/16 steel also. So both sides of this piece of metal I had to cut here and here, and I just used jigsaw and a metal cutting blade and was patient with it, and that's all I had to do. All right, so all in all, this was a relatively easy installation for me, because this is just basic mechanical work. I've been doing this kind of stuff my whole life. Drilling the holes through the frame was very tough. That was about a half a day to get those holes drilled. You know, making the little bracket for that took me some time. Pulling the wires through the frame, that took some time. I think I've been working on this for about 4 days now. Not full time, because I've been waiting for parts on and off. But very happy with the result. And I'm going to go inside the bus now, and I'm going to close up the electrical panel, because I'm done messing around with all that stuff.